Okay, we will do one example in Fourier transform. Okay, so this is your first question of your mid-semester exam paper. Okay, I hope it is not a difficult one. Easy question. Okay, we have to evaluate the Fourier transform of this signal. Okay, so I will take this signal. So we have to evaluate the Fourier transform of this signal. Very easy, no? Okay, so we will do it. So, and in the exam paper, also, sorry. Okay, in your exam paper, also you are given the principal identity, okay, Fourier transform pair actually. Okay, so you can use it directly, okay. So you are asked to find the Fourier transform of this signal, this xt. Okay, so already you know how to find the Fourier transform using the first principle. So if we found the Fourier transform of this signal, okay, so this is a time domain signal and it will be converted to frequency domain signal, and it is denoted like this. Okay, x omega. So you have to find this x omega. Okay, so we know the relationship. X omega is equal to minus infinity to plus infinity. Okay, our time domain signal should into e to the power j omega t dt. Okay, so this is the identity. In our exam paper, it is given. Okay, so let's try to do this. Okay, so you can see that when you look at this signal, it has two parts. No, this is one part and this is another part. Okay, and this part is also given, that is x equal to t, that is from 0 to 1. No, x is 0 to 1, and this part, okay, it is a DC part. No, it is a DC part, and there x is equal to 1 xt. Okay, and this one also xt. Okay, it again, xt here equal to t within this limit. Okay, and xt is equal to 1 within 1 and 2. Okay, so you have two parts. Okay, so you have two parts, so you have to evaluate this integration separately. Okay, so you have to evaluate this integration separately. It is not much difficult. Okay, so here we have x omega, and it is equal to 0 to 1, 0 to 1, this part, no, 0 to 1, this part, that is t. Okay, and e to the power minus j omega t dt plus 1 to 2, 1 to 2, okay, 1 to 2, it is just 1, no, it is just 1 e to the power j omega t dt. Okay. So this is what we have to evaluate. Okay, so you can see that if you consider this part, okay, we have to use integration by parts, no, integration by parts to evaluate this component. Okay, so we use it. Okay, so I will get this part only, 0 to 1 t e to the power j omega t dt. Okay, so so we have to select this term as u, says u, and this term as dv by dt. Okay, if you select these terms as v, when you have to sorry, if you select this by du by dt, then you have to evaluate the u, so you have to integrate it, then it will become t square by 2, no? So the order is increasing, so you can't do the evaluation. Okay, so you can't do the integration. So this way you have to select. Okay, these two function u and this derivative function dv by dt. Okay, I hope you got it. If you have any problem, you can ask. Okay, so so if I evaluate this derivative, so u is equal to t, and if I evaluate du by dt, it is 1. Okay, and this is dv by dt, it is e to the power minus j omega t. Okay, so if I want to find v, okay, we have to integrate this with respect to dt with respect to t time. Okay, so we have e to the power minus j omega t by minus j omega. Okay, so you have this part. So if you write this, okay, so I will write this here. Okay, so here we have, I have to write it as, you can remember that we have to write it as uv minus integration v du by dt. Okay, so this way we have to write, no? So I will write it uv, okay, u is t, v is e to the power j omega t minus j omega. Okay, so this is 0 to 1. Okay, this is the lower limit and this is upper limit, 0 to 1. Okay, and minus integration v is v sun e to the power minus j omega t minus j omega. Okay, and du by dt, that is 1. Okay, so I think you can directly evaluate this integration. Okay, so if I write here, okay, I will write it here. Okay, so I can write, if I integrate 0 to 1 this t e minus j omega t dt, I will get t e to the power minus j omega t minus j omega 0 to 1. Okay, and minus if I integrate this, I will get e to the power minus j omega t itself, and minus j omega minus j omega minus j omega into minus j omega, that means j omega square. Okay, so it will be plus, and here minus, so we will have minus value. Okay, so this is also from 0 to 1. Okay, so if I apply these limits, lower limits and upper limits, okay, so if I apply this limit, lower limits and upper limits, so we have 1 to e to the power minus j omega to the power minus j omega. Okay, and minus j omega minus 0. Okay, so this part I will have this one, and here also I have, this is 1 to 2. Okay, so 1 to 2. So here we have e to the power j omega 2. Okay, so t is 2 here, and j omega is square minus e to the power uh, e to the power minus j1. Okay, and here also j omega is square. Okay, so we will have this part. Okay, And you can see now we can find the total integration. Okay. So this is this result, this result, this result will come to this integration, no? This integration. And this integration we can directly evaluate, no problem. Here we have e to the power minus j omega t, j omega, okay, from 1 to 2. So this is the answer here. So you can apply the uh, limits here also, okay, for this, okay, limit. So I evaluate this integration, okay. So this integration, this part, okay. So this part integration I evaluate here. It is e to the power minus j omega t, and here j omega, okay. So sorry, minus j omega, okay. So 1 to 2 limits. So if I apply the limits, I will have e to the power minus j omega 2 by j omega minus, okay. Then I have minus, then minus minus it will be plus, okay. So I hope these are very simple, so you can get it, okay. That is why I just skip this step, okay. But if you have any problem, any query, you can ask, okay. So here we have e to the power minus j omega 1 and minus, sorry, minus cancel, minus minus plus. So it is j omega, okay. So I will have these two parts also. Okay, so if I write the total integrated signal, if I write the total integrated signal, that is x omega, no? Okay. We have first this part. So it is e to the power minus j omega minus j omega. Okay. And 0. So another one we have e to the power minus j omega 2 j omega square. So you know that j omega, j square, j is minus 1. So this j is equal to minus 1. J is minus 1. Okay. So if you square this, sorry, minus, sorry, root of minus 1, okay? Square root of minus 1. Square root minus 1. J is equal to square root minus 1. You know the complex number. Okay. So if you square this root minus 1, you will have minus 1. Okay. So when you square j, okay, so j squared is equal to minus 1. So here minus 1 and minus, it will be plus, okay. And we have only omega square. Okay. And here we have minus minus plus, okay. This minus and this minus, it will be plus. And j square is minus again. So we have minus here. J, okay, by omega square, okay, j1 here, okay. Sorry, omega is there, sorry, omega is there, okay, j omega is there, okay, j omega. And other two terms for this integration, okay. So we have e to the power j omega 2, okay, minus e to the power j omega 2 minus e to the power j omega 2 by j omega, okay, and plus e to the power minus j omega 1 omega plus e to the power minus j omega 1 omega. So you can see that this one and this one is cancelled, okay. So you have only three terms, okay. So e to the power minus j omega 2 omega square minus e to the power minus j omega 2 j omega minus e to the power, here it is minus, no, minus j omega by omega square. So this is the answer. If you write it up to here, you will get the full marks. Okay, and you can see that you also can turn this to a using the Euler formula to you can turn this to sine value, sine signal. Okay, and there is omega square and sine 2. Okay, so sometime you maybe write it with the sinc function or with sine or cos terms. Okay, sometime you can express this. Okay, so anyway, up to this point, if you evaluate, it is okay. Okay, so now you can see that here only we have omega terms. Okay, omega terms. This omega is also variable. Okay, but when we are doing the integration with respect to t, we consider this as a constant. Okay, so finally we have a function with respect to omega. So this omega is our variable now, independent variable. So this is the omega domain signal. That means this is a frequency domain signal. Okay. So we have convert our time domain signal to the frequency domain signal. Okay. I hope you got it. We will move to the next one quickly.